Okay, so we have this graph. Anything that could possibly happen happens on this graph, okay? Because I wanted you to think through all the possible scenarios that could occur. We are going to first identify the roots and the asymptotes. We will create factors from them, paying attention to whether or not those factors need to be squared. And then we will write a general form, plug in a pretty point, which we have right there, solve for A, and write the final equation. So those are our steps here. So remember that root information goes on top, and asymptote information goes on the bottom. Bless you. So my roots are right here. 1, 2. There are 2 roots. This farthest left one is at -4, and the right side one is -2. So my question for you, as I set up my fraction, my rational function, what factor gives me a root of -4? X plus 4. And my next question for you is, what's the behavior at that root? Is it bouncing or crossing? Bouncing. What does that mean for its exponent? It's squared. Okay. The other root is -2. The factor that gives me that is x plus 2. What's the behavior at that root? A cross or a bounce? Crosses. So what's its exponent going to be? 1. Sorry. Not 2. And then for the asymptotes go on the bottom. We have 2 asymptotes right here. This one is at x equals -3. And this one is at x equals +2. So the factor form for x equals -3 is x plus 3. And to figure out if that's squared or not, you're looking to see if it's coming together on either side of the asymptote. So we have the asymptote here. This side is up, this side is down. Is that together? No, it's opposite. What does that mean for its exponent? 1. For this asymptote, the factored form is x minus 2. On either side of that asymptote, it's going the same direction. That's together. So what does that mean for its exponent? Squared. So that was our first step. We determined the factored forms of the roots and the asymptotes. The next step was to set up the general form for the function. So it's y equals and then some a value that we're going to figure out what it is. The a is just some constant that's part of the problem that we need to determine. And so the way we do that, the way we figure out what a is we plug in a pretty point. What pretty point did I give you? Right here, -1, 1. So that's an x and that's a y. So wherever there's a y, you put +1. Wherever there's an x, you put -1. So y equals a times -1 plus 4 squared times -1 plus 2 over -1 plus 3, -1 minus 2 squared. So for order of operations, what do we do first for order of operations? Parentheses, right? Welcome to math class. Okay, good job. So doing parentheses first. Not exponents first, right? So simplifying your parentheses gives you this. 3 in this one, that's going to be squared eventually. Then 1. That looks like a 9, that's an a. And then, I don't think that's an improved a, but you know that is an a. Then we do exponents next. Don't be multiplying before you do the exponents. It's going to mess up your stuff. So 3 squared is 9 times that 1 over, what's -3 squared? +9, right? Not -9. So it's +9. I like to cancel the 9 out here. You certainly don't have to. You could just multiply across the top and the bottom and figure it out later, but I like to cancel it out now. And that would give me 1 equals a times 1, which is a, over 2. How do I solve for a from here? Multiply by 2, right? Sometimes when it's been a while, then we solved, we get something really simple like this, and suddenly we're like, I don't know. Don't overthink it. Okay, we're just multiplying both sides by 2. So 2 equals a. And that was a whole bunch of work. And so right here, it kind of feels like, oh, we're done. Good job, guys. We found a. But that's not actually our goal, right? Our goal is to find the equation of the line. So we take that a equals 2 and plug it back into the general form all the way up there. Okay, and that's going to be our final answer. So y equals 2 times x plus 4 squared times x plus 2 over x plus 3, and then x minus 2 quantity squared. Did anybody get everything right, including the exponents? Now, if you had forgotten to square, you still would have got 2, because it just so happens that the numbers that were squared happen to be the same number. It gave you the same value. So that's a coincidence if you got it right on accident. That's why, of course, why I always want to show work, because I have students say, I got the answer right, but sometimes people get the answer right on accident. And I'm more concerned about your process. What do you notice about the a value, or did you? There's something else going on between the a value and the graph. Do you see it? The horizontal asymptote, okay? The horizontal asymptote is a equals 2, and that makes sense because if you FOILed all this out, if you multiplied everything out, that 2 would come along every single time, like a distributive property. And when you found the leading terms, like x cubed up here and x cubed down here, it'd be balanced, and you would simplify and get 2. However, I want to caution you not to always still do the algebra, because sometimes, even if you have a horizontal asymptote, most of the time, that's your a value on a balanced equation, but not every time. So still do the algebra. The algebra you can use the picture as like a self-check of your algebra. Like if you didn't get 2 and the horizontal asymptote was 2, that's your first sign, oh, maybe my math is wrong. But I still want to encourage you to do the math, because we're not really going to be trying to trick you, but let's say you're in college next year and it's college algebra and you happen to remember this one random lesson out of this whole school year. And you're like, oh, it's the horizontal asymptote. But if they're giving you something trickier, like where there's a -1 somewhere in there that needs to be factored out or something like that, it's going to mess it up. Or this was all integer values. If it was a fraction value, that is very hard to determine from a graph, and you would want to be able to do the algebra in case a was like, 0.7 or something weird like that. My point is, please do the algebra. Use the picture as a double check. Any questions about that warm-up? Any questions about the homework that was like the warm-up? The writing the equations? Any stuff there? Any questions? Okay. Real quickly, just as a very easy. It's the last new material. It's probably the quickest, easiest one from the whole unit. It's the H part of the Schrady. So today when we simplify in that first step, we do factoring, we will be canceling out a common factor. All right. So did everybody get a word? Bless you. All right, do the S step for number 1. While you're doing that, I'll just read to you what it says up there on the box. It says a discontinuity is an undefined point in the graph which occurs if the numerator, this is a typo, the numerator and denominator have factors in common that cancel out. And a hole is an undefined point in the graph where there usually would have been a vertical asymptote. So it's a point when we would have had a line instead. So take a minute and factor. So the S step is factoring. How does the numerator, yes? Would you like the notes? Thank you. Okay. So make that correction right there at the top. That was a typo where it says number. It's supposed to say numerator. And I want you to do the S step of shading. How does that numerator in number 1 factor? What's that method? Difference of squares, right? Difference of squares. So the numerator, and then let's say you don't ever remember difference of squares, but you're good with the AC method, the swing method. You could say what multiplies to negative 16 and adds to 0, and you'd get 4 negative 4, which would give you the same thing. So I've got x minus 4 over x plus 4 all over the denominator, which is x minus 4. And part of the S step is still you cancel something if it can cancel. We haven't had that situation yet, but that's all we're doing today. What cancels here? Okay. Not negative 4s. It's the whole group, the whole x minus 4 is what's going to cancel. And the reason why you can't cancel the negative 4s is they're attached to the x. They go together. And so that leaves me x plus 4. And what I want you to understand here at this step, this is now my function that I'm graphing. What's that going to look like, x plus 4? It's a line, right? We're not going to have any vertical asymptotes. We're not going to have any end behaviors. We're just graphing a line with a hole in it. And what's going on here is that in the original function, there was an x squared up top. We divided it out by an x that dropped my degree by 1. So it changed the shape of the function. So now, from here on out, we will mostly be using that x plus 4. For the H step, we're using what we canceled. So I want you to take a minute, and I want you to look at your Schrade sheet and just read the H information before I talk about it. I just want you to look at it. Okay. So if you're reading the H part, it says, if any factors canceled above, they create holes in the graph. Set the factor equal to 0 and solve for x. What was my factor that canceled? And what am I going to do with it? Set it to 0. And then you solve for x, you get x equals 4. It says, then what? It says, plug the x value into the simplified. See that word simplified? It's bolded and underlined. So plug the x value into the simplified equation to find the y value. Write your answer as a point. Because what's happening is this. When nothing canceled in our old problems, and I still had x minus 4 on the bottom, and I wrote x equals 4 here as a vertical asymptote, it was a line. But what's happening now, it's not a line. We dropped it by a degree, and it's going to be a point. And so in order to know where the point is, I need 2 pieces of information. I need the x and I need a y. So I have an x now. I have x equals 4. How do you get a y? When you have an x, you plug it in, and you solve for y. The question that you're going to be, when you start doing problems on your own is, am I supposed to plug that into the original or the simplified? That's why it says simplified there in bold, underlined letters. Right? So that's what I'm going to do now. I'm going to take that x equals 4. I'm going to take the simplified version, and plug in 4 for x. Now this is an unfortunate problem where there's 4s everywhere. That's just coincidence. Just follow the words of the steps and don't draw any conclusions, like the numbers always have to be the same or something like that. So this was my x equals 4. What's that 8? What is that? That's a y, right? And so my point, so this is y, this is x. So the point for the whole, the undefined piece, is 4, 8. And when you go to plot that point on your graph, it's going to be an open circle because it's undefined there. So I'm going to put an open circle at 4, 8. And again, the reason why x cannot be 4 is if you plugged it in to the original function, it would make 0 on the bottom, which is bad. You cannot divide by 0. What's the next letter for Shrady? R, that's for roots. That's your x-intercept. It's where it crosses the x-axis. That's where we set normally the numerator equal to 0, but I no longer have a numerator. I just have one thing. I have x plus 4. So I'm going to set that equal to 0. I'm still using the simplified form. So x equals -4 for the roots. Do I write that as a point or as a line? Perfect. So it's -4, 0. So I'm going to put that on my graph. So right now I have a closed circle at -4, 0 and an open circle at 4, 8. And I think you're going to like this next part. Bless you. For AT and E, not applicable. We don't have to do that at all. Because we're just graphing a line, and it doesn't make sense to talk about asymptotes and stuff with a line. And y works the same. It's for the y-intercept. What do we plug in 0 for here? X. Into the simplified, right? Because once we simplify, this is now my function that I'm graphing. So when I go to find a point on there, I use that highlighted part. So I'm going to put 0 in for x. That gives me 4. So when x is 0, y is 4. And we already knew it was going to be 0, 4 because it's in slope-intercept form, and the b is 4. So I'm going to put all those points on my graph. I'm about to slide up. Does anybody need this work here anymore? And then here's what I got. A line with a hole in it. And what we're going to do with the next example is I'm just going to sort of take you through each letter and give you some time to think it through, read your Shrady and do it. And then we'll talk about each letter after a few moments. So I want you to get started on the S step for number 2 by factoring the top and bottom where possible. And it has been a while since we practiced factoring. Do you remember what method that's called in the numerator? When you take out, like, it's not a trinomial, so we can't do swing. Greatest common factor. It's not difference of two squares. It's a GCF because both of those terms have something in common. What do they have in common? X. Right? So what you do is you write the GCF down, you write X down, you put some parentheses, and you write the leftovers in the parentheses, what you get when you divide x out of those terms. So in the first term, 2x squared, you take 1x out, you're left with 2x, and then in the second term, you're just left with 3. So what's canceling out here? 2x minus 3. What does that leave me with? Okay. So this is now my new simplified equation. So what's my graph going to look like? Is that a line also? In fact, that's our identity parent function. Y equals X means everything, Y and X are equal all the way throughout. It's identity. So read the H part, please, of your notes, and don't holler out anything about what to do next. I want everyone to grapple with it themselves. So read through the H. Read all the words. One thing, so I want you to make a note right here on your H sheet, on your H part. It says set the factor equal to 0. That might be a little bit misleading. We have two factors right there. Which factor does it want you to do? The one that canceled. So if you need to make a little note somewhere on your H part when it says set the factor equal to 0, put a note on the side. The factor that canceled gets set equal to 0. Okay? The factor that canceled. And so in this case, which factor was that? The x or the 2x minus 3? 2x minus 3. And what's, okay, I won't say it anymore. So 2x minus 3 equals 0. And so after it sets equal to 0, it tells you to solve for x. So we add 3 to both sides and get 2x equals 3. Divide by 2, and I get x equals 3 halves. So we've only done that middle piece. It says set factor equal to 0 and solve. What does it say to do next? Plug the x value into the what? What does that word say in there? Simplified. Okay. It says plug the x value into the simplified equation. What was my simplified equation? X. So remember, the reason why we're doing that is we're trying to put an open circle at the points. And for a point, we need two pieces of information, x and y. So I have x, I need the y. What happens when you plug 3 halves in for x on this function? What do you get? 3 halves. Okay, 3 halves. You're plugging it in, there's nothing else to do. So why is that? So my point, writing it, and then your sheet says write it as a point. So the point is 3 halves, 3 halves. What kind of dot am I putting at that point? Open, right? Because that's the hole. That's the discontinuity. So 3 halves is 1 1/2. So at 1 1/2, 1 1/2, I'm going to put an open circle. For R is a root. We always set it equal to 0 and solve to find the root. What am I using for that? Your x, the simplified equation. Because remember, this has taken the place of the original function. I'm only concerned about what this graph looks like. Hold on. So, did I stop the thing? Ah, I didn't stop the thing. What did y'all do next? What did you get for your root? 0, right? Because you're letting x equal 0. You're solving, but it's already done. So that point is 0, 0. And then the ATE, what's going on there? Nothing, right? A big old fat, not applicable. And then y, you let x equals 0. X is already just x. What's your y-intercept? 0, 0, which we knew that was going to be because the x-intercept is already 0, 0. So your function, just graph it. Looks like this. All right. You have your homework already. I'm going to go over the quizzes now. So if you did not take the quiz yesterday, please get out for a few moments while we go over it.